Okay, today we're going to work on page 266. So we're doing 1 through 24 all, and it's actually pretty easy. In the first set, you're just determining if something is a polynomial. Yeah, 1 through 24 all. So 266, 1 through 24 all. What does it mean to be a polynomial? So something like 6x to the fifth minus 4x to the third plus 2x squared minus 6x minus 4. That is a polynomial. What is the degree of that polynomial? Degree is the largest exponent on a variable, that is. So 5, and this has 1, 2, 3, 4, 5 terms also. So it's a 5-term, 5th degree polynomial. Okay? And we can set up a lot of rules for polynomials, but the simplest is this. All exponents have to have whole number, all variables have to have whole number exponents. So if I had something like 6x squared minus 5x to the 1.3, that is not a polynomial because this is not a whole number. Okay, if one of the exponents was negative, that is not a polynomial. If you had something like 1 over 3x, the 1 over 3 is not an issue, but the x in the denominator is a problem because if I move that to the top, it's x to the negative 1. If you have a variable inside a square root, that's x to the 1/2, which is not a whole number. So if you look on page, hang on, I gotta get there. Okay. All right, so let's do some of the practice exercises on 256. Okay, is A a polynomial? Yes. And 3 is actually 3x to the 0, and 0 is a whole number, so that's okay. What about B? No, square root of x is actually x to the 1/2, so that's not a polynomial. Okay, what about C? Is that a polynomial? Yeah. 2x to the 0. What about D? Well, the specific type would be monomial because it has one term. So this one is a 2-termed polynomial of degree 5. So you could call it a binomial with degree 5. What about D? Yes, what type of polynomial is it? Trinomial, and what's its degree? The biggest exponent is 2. What about H? Is it a polynomial? If we multiplied it out, it would end up being a polynomial. Can you figure out what its degree would be? So this is actually x squared, right? So you have x to the 5th times x squared, which is x to the 7th. That is the degree. Do I know how many terms it has? Well, when I square a binomial, how many terms do I get? 3. And when I distribute in another term, how many terms do I get? So this piece here is going to be something like ax squared plus bx plus c. It's a trinomial. So if I take 4x to the 5th and I multiply it into each term, do I get more terms? No, I still have 3 terms. They just got bigger, but I haven't added any terms. So this would be a 7th degree trinomial. Okay, F. Is that a polynomial? That x to the -2 is not a polynomial. Also, if you had some trig functions in there, that would ruin it. Absolute value. Anything other than just regular x's raised to powers would not be a polynomial. Okay? So, we need to talk about the shape of polynomials. What does a degree 0 polynomial look like? It is a line, but it's more specifically a horizontal line, like y = 6. So that is just a horizontal line. What about degree 1? It's a slanted line. Whether it slants up or whether it slants down, it's a non-horizontal line. It has a slope other than 0. Okay, what about degree 2? It's a parabola, could open up, could open down. What about degree 3? So degree 3 is a little bit tricky. It can either look like this and have an inflection point or a saddle. Do you guys know what inflection means? So when you get to calculus, inflection is really important. And inflection means it switches from concave up to concave down or backwards. So if we were to turn this piece into a parabola, can you see how it opens down? And if we were to turn this piece into a parabola, see how it opens up? So the left half is considered concave down, and the right side is considered concave up. And when you switch from concave up to concave down, that point is called an inflection point. Okay? But that's not the only thing an x to the third can look like. What else can it do? It can have 3 roots, meaning it looks like this. In which case, it still only has one inflection point, right? So we have a concave down and then a concave up. What about a degree 4? So a degree 4 can look like a W and hit the x-axis 4 times. Or it can look like a parabola, or it can actually be a mix of a parabola and an x to the third. So it could go like this, come down like that. Do you guys remember the difference between single, double, and triple roots? If a root happens once, then it passes right through. What happens if a root is a double root? It bounces off. So we could have a double root there and a double root there. And it's still an x to the fourth, but it bounces off. What about a triple root? A triple root has this inflection point like a saddle. So that is a triple root. So this x to the fourth is made up of 4 unique roots. This x to the fourth is made up of 2 double roots. This x to the fourth is made up of 2 single roots, and then we're not sure what happens with the other ones. And then this one is a single root and a triple root, and then you could have lots of other examples where you have imaginary roots and the like. So if I just randomly drew a graph, what can you tell me about that graph? So 1, 2, 3, 4, 5. So it's an x to the fifth, or it could also be x to the any odd number higher than it. It could be a 7, it could be a 9. How do I know it's not an 8? Well, if the two ends, if the end behavior is different, if one goes up and the other goes down, what do you know about the polynomial? The degree is odd. If the degree is even, then the two end behaviors are the same. It's either up, up, or down, down. So if you look at, do they have some practice? Okay, so if you look at 11 in your problem set, 11 through 18, you have 8 equations, and you have to match it with the appropriate graph. Now, you could do it the slow way and graph them and match it, or you can just look at what's there and eliminate them according to the possibilities. Okay? So, what if I wanted to do transformations? They don't have any x to the firsts, do they? 4, 5, 4, 5. Okay. What does, so we know x squared looks like this. We know that x to the third looks like that. What does x to the fourth look like? If we just graph x to the fourth, what would it look like? It's going to look like x squared, but it's going to be a lot steeper. Right? 0 to the fourth is 0. 1 to the fourth is 1. 2 to the fourth is 4 times 4, which is 16. Whereas here, you'd have 1, 1, and then 2, 4. So x to the fourth looks just like x squared, only it's much taller. It's x squared taller than the original x squared. So what would x to the fifth look like? Well, it's going to look just like x to the third, only much taller. So if I wanted to do x minus 3 to the fifth plus 1, where would that graph be? So right 3, up 1. So we would take this inflection point, and we'd go right 3 and up 1, and then it would be a really skinny x to the third graph. Okay? Easy enough, right? All right. Good luck.